Imagine you've developed an online marketplace where users can sell items to others. To facilitate transactions, the application stores users' credit card data. Since securing this information is crucial, multiple security measures are implemented: strong encryption, access controls, and internal security restrictions to protect the database. However, a single, seemingly minor vulnerability at the application layer can bypass all these defenses, exposing sensitive user data to attackers. This vulnerability is known as CORS Misconfiguration, a serious security flaw that can grant hackers unauthorized access to private information. Before diving into the vulnerability, let's first understand cross-origin resource sharing, CORS, and its role in web security. When you load a web page, it consists not only of HTML, but also multiple pieces of JavaScript code, often loaded from different origins. While loading JavaScript from external sources improves functionality, it also introduces security risks by potentially allowing external domains to access user data. To mitigate these risks, browsers enforce a security mechanism called the Same Origin Policy, SOP. This policy restricts JavaScript from accessing resources unless they originate from the same origin, defined by scheme or protocol, domain name, and port number. Thanks to SOP, external scripts cannot directly access user data, preventing malicious cross-domain interactions. However, web applications often need to share resources across multiple domains, for instance, when integrating with public APIs. This is where CORS comes into play, which is implemented into the browsers as a controlled relaxation of the SOP. CORS enables controlled access to resources across different origins while enforcing security through predefined rules. For example, api.online-marketplace.com can explicitly allow www.online-marketplace.com to access its resources by specifying the appropriate origin header. A vulnerability arises when developers fail to properly validate which origins are allowed to access JavaScript resources. If an application is configured to accept requests from any origin supplied by the client, it becomes vulnerable to attacks. An attacker can exploit this by hosting a malicious website with JavaScript that requests sensitive data from the vulnerable application. If a victim visits the attacker's site, the malicious script executes in their browser, sending a request to the vulnerable application. Since the CORS policy improperly allows all origins, the application unknowingly grants the attacker access to the victim's sensitive data, such as credit card details or personal information. This misconfiguration effectively bypasses all other security controls, making CORS misconfiguration a highly dangerous vulnerability that can lead to severe data breaches. To identify a CORS misconfiguration, you can manipulate the origin header in a request, for example, setOrigin, attacker.com, and observe the response. If the response is this way, the application is vulnerable to the CORS-based attacks. Once the vulnerability is identified, an attacker can execute a simple JavaScript payload on their website. When a victim visits the site, this JavaScript runs in their browser, sending a request to access their sensitive data. Due to the CORS misconfiguration, the attacker gains unauthorized access. To prevent this vulnerability, follow these best practices. Strictly define allowed origins. Never use wildcard unless absolutely necessary. Use a whitelist of trusted origins to control access. Regularly audit and test your CORS configurations to detect misconfigurations early. Hope you enjoyed this video. Stay tuned for more interesting educational videos on cybersecurity.